Hello everyone, hope everybody's having a good morning. We're here to present our term project in which we've been working on this the entire semester, and we called it the oxygen cable tender, and it definitely assists those who are in need of an oxygen tank, wherever they go. And this project is by Vincent Key, Mohammed Nayar, and Richie Palaya. Alright, picture this. We have an old lady who is highly dependent on an oxygen tank. Wherever she goes, she has to have it rolling behind her just for her to live. Alright, now imagine her at home just doing simple activities, and she's just walking around in her room and she just boom falls over because of the extra hose that is just laying around. And that is definitely not what we want, because she's actually hurting herself with the oxygen tank. So as an engineer, we had to think, what should we do? So we'd actually have the idea of having it on top of the room, the hose, instead of being on the floor. So on the bottom we'd have the oxygen tank, which the hose would flow right on top of it to the cable reel, which would also be attached to the stepper motor. And then in between the stepper motor and the pulley, we'd have this tension arm, which should actually be a potentiometer, and it would dictate whether the stepper motor should wind or unwind, depending on how the tension is and how the user at the end of it would, how far they would be.
Hi everyone, my name is Mohammed Nair and I'm making this project for 106 class, and this is the circuitry for the project. This is the stepper motor that we use for this project, the driver board for this, the solderless breadboard, a 9-volt battery, Arduino Uno, the connecting USB cable, and some jumping wires. We use the lab manual to set up the stepper motor and hook it up with the driver board. We used the connecting wires to connect it to the solderless breadboard and power it with the external 9-volt battery source. And then we connected everything to the Arduino. And Arduino is also connected to the potentiometer that is connecting to the front. It has a pulley on the top to sense the tension. And this is the close-up of the potentiometer, and it is used as a tension sensor.
Okay, I'm Vincent, and this is the mechanical side of the oxygen tube tender of our project. Right over here is the reel that we use to wind up the cable. Inside here we've cut a hole into a sort of a cardboard roll that we constructed earlier. The cardboard roll is attached to one of my old center caps on my old car that I've used to create the hub that's attached to the D-shaped shaft on the stepper motor. As you can see, as the motor turns, it'll wind up the cable. Over here is a potentiometer. What we use to create an arm to sense the tension on the oxygen tube is this arm I created in the San Jose State machine shop. It's not very refined, but it does the job. Since the potentiometer, the only real method of fixing something onto it would be the gap between the middle. The arm fixes on by falling into this gap, and by this way you can sense the tension. In the front here is a pulley to lead to the user of the oxygen tube.
Alright, here is our up and close view of our project here. We got this tubing which is connected to the oxygen tank, which is connected to this reel, which is where it comes here to the tension arm and to the pulley, where she is having the oxygen mask right here on this side. Now we actually added this screw here just so that this arm does not come on this side, which we don't want. We kind of set it up to be this side. We don't want it to end up rolling over to this side. So right now we have it set up as the old lady walks kind of far, and she wants to walk back to a previous spot, which would leave tubing on an extra tubing list laying around. And so we actually want it to wind up because there's extra tubing. So you can see here this tension arm is less, it kind of went down, just saying, okay, there's more, there's extra tubing around, so we want it to reel up. And see, now once she got kind of, the tension is tighter now, so now she wants, say she was at that spot, and now she wants to move from that spot a little farther, and you can see the arm coming up here, and then they see this unwinding, because you want to give more tubing for when she goes farther. So that's how we have it as.
This is Vincent once again.
And this is Richie once again.
Once again, this is Mohammed Nair, and thank you for watching our video, our successful project for 106 class, which was Mechatronics, Introduction to Mechatronics. We built this project for San Jose State University for Dr. Furman. And once again, thank you for watching our video.
Thank you for watching me
Thanks,
play
guys.
with the vinyl hose for 30 minutes.